So today our topic is how to calculate pH from the concentration of the solution. Okay, so this is very simple. The first step that we really need to make sure that we know is what is pH. So let me just change the color real quick. So we know that pH is basically the negative log of hydrogen ions. That's it. It's that simple. So this is the whole core concept of this video today. pH is the negative log of hydrogen ions. Now the trickiest part here is to calculate and to know that what is basically the concentration of hydrogen ions in a solution. That is the main thing. Now, in order to calculate the hydrogen ions concentration, we need to first understand what we are dealing with. The solution could be a strong acid or base, or it could be a weak acid or base, or it could be a buffer, right? So in this video we will cover the first two real quick, and this one we'll just mention in another video. So first of all, let's have a look on the strong acids. Okay, so the second step, we will just look at the strong acids. So strong acids such as HCl, nitric acid. We know the strong acids, they have the tendency to dissociate their hydrogen ions pretty easily. So almost all the molecules present in a strong acid will dissociate hydrogen ions. So that means the concentration of strong acid would directly correspond to the concentration of hydrogen ions in the solutions. So let's take an example. So for example, we have a solution of HCl which is 0.01 molar HCl. You will find it like all the time in different labs, like different molarities of HCl. So 0.01 molar solution of HCl. That means that this solution has 0.01 molar hydrogen ions, because almost all the molecules of HCl, they are giving away the hydrogen ions. Cool. So now that means we got the concentration of hydrogen ion. The next step is really simple. You just take the negative log of this concentration, which is 0.01. Now if you do have a calculator, you can easily solve the equation, but if you don't, I'll give you a trick to solve this equation without having a calculator. So what you have to do is to convert this fraction into the scientific notation. So that will be 1 into 10 raised to power, because this decimal point moves towards right, and we get 2 with a minus on it. So because this is a base of 10, what we will do is the minus log. So the answer will be, because log is also the base of 10, so the answer will be the minus 2. The power of the base of 10 would become the answer of the log. So the negative log of 1 into 10 raised to power minus 2 would be minus 2, right? So now it becomes really easy. So minus, you multiply minus with the minus, it becomes 2. So the pH of 0.01 molar HCl is 2. So as you know that pH 2 is a pretty strong acid. That's it. So I think that was pretty easy to know how a strong acid's pH can be calculated. Now if we talk about a strong base, so let's change the color again. Let's do blue one this time. Let's decrease. Okay, so the pH of a strong base. So for example, NaOH, sodium hydroxide. Again, when we are talking about the base, we are looking at the POH instead of pH, and this is the same thing, the negative log of hydroxide ions. Okay, as soon as we know the hydroxide ions concentration in the solution, it is really easy to find the pH, because pH would be 14, which is the maximum scale on the pH, minus POH, and that would give us a pH of the base. So here we are talking about a strong base. Okay, so let's again take the same example, 0.01 molar sodium hydroxide. We know that it's a strong base, it will give away the hydroxide ion pretty easily. So the concentration of hydroxide ion will be, which is negatively charged, would be 0.01 molar. So the concentration of hydroxide ions will be 0.01 molar. Now, just put this in the equation that we have. POH is equal to minus log of hydroxide concentration, which we know is 0.01, and now we know that this gives us the answer 2. So POH is 2. So be very careful, this is not the pH, this is the POH. So pH will be 14 minus POH, which is 2. So the pH will be 12. So this is our answer. So we know sodium hydroxide is a strong base. So 0.01 molar solution of sodium hydroxide will have a pH of 12, which is pretty basic. Okay, so with this out of the way, what was the second thing is the weak acid or base. So let's discuss that to close the topic, and this time we are using the black color. So weak base, acid or base. So the difference between a weak acid or base and a strong acid and base is the capacity or capability of that acid or base to give away, to dissociate their ions, hydrogen ions in case of acids and hydroxide ions in case of the base. So strong acids dissociate pretty easily, weak acids don't. So in this case, we cannot say, the formula will be pH equals minus log of hydrogen ions concentration, but this hydrogen ions concentration is not directly equal to the concentration of solution, because imagine there are 100, okay, not 100, let's say there are again 0.01 molar solution of acetic acid, which is a weak acid. So we know that acetic acid will not dissociate the hydrogen ions easily. So maybe half of the molecules dissociate hydrogen ions and half do not. So that means there is another factors now adding, which is called dissociation constant. Dissociation constant, which is represented by Ka. So the formula of pH will not change, because the formula is the pH is minus log, negative log of hydrogen ions. It's just how we calculate the hydrogen ion concentration would change. So hydrogen ion concentration, which were equal to the concentration of the solution in case of strong acids and acids, in case of the weak acids, that would add another layer of factor, which is Ka. So Ka and multiply by C, and then take the under root. Now Ka we know is a dissociation constant and C is the concentration of solution. So you need to know what is the Ka, which is the specific property of every weak acid. You need to add that, and then you have the concentration. You take the under root and you get the hydrogen ion concentration. Once you get that, you put this value into the core formula of pH, which is the negative log of hydrogen ions, and you get the pH. So the final thoughts. What are the factors that may impact the pH is, first of all, is the temperature, because the temperature shifts the neutral point. So temperature of the acids are really important. Strong acids and strong bases, it's easy to calculate their hydrogen ion concentrations or hydroxide concentrations because they dissociate quite easily. Weak acids and bases, for weak acids and bases you need to factor in the Ka, which is a dissociation constant. Finally, the concentration of the solution is really important because concentration changes the pH. Higher the concentration of acid, lower will be the pH, and the same goes for base. Higher the concentration of base, higher pH will be, because strong bases have high pH. And finally, in case of buffers, we cannot use these equations to calculate their hydrogen ions concentration or hydroxide ions concentration, because these are the buffer solutions which are a mix of both acids and bases. So for that we use Henderson-Hasselbalch equation. This we will discuss in another video. Until then, have a good day. Bye bye.